With so much transformation work focused around the virtualization of network functions, where does this leave CSPs, especially with increased discussion around cloud native? Martin, good to see you again on TelecomTV. Now, you and I have been speaking about cloud native for a number of years now. It looks maybe finally that the rest of the industry is catching on and has caught up.
Well, they're certainly using the words. I mean, they're words we started using, I guess, 3 or 4 years ago. And all of the network operators are saying stuff should be cloud native. Sometimes I wonder whether they necessarily actually understand all of the ramifications and implications of that. I mean, I attended a keynote by one of a big tier 1 telco today who said, well, cloud native isn't enough. You know, you still have to pay attention to security and lifecycle management and so on. Well, but actually cloud native means you do pay attention to those things. A properly architected cloud native application in a cloud native environment is incredibly secure and intrinsically orchestrated and lifecycle managed. That's what cloud native means.
So let's encapsulate then. What is cloud native, and how does a CSP achieve that status?
So we turn to the Cloud Native Computing Foundation for the kind of canonical definition of what cloud native means. And what they say is a cloud native application should be, number 1, deployable in containers, number 2, decomposed into microservices, and number 3, dynamically orchestrated. Now, it might be worth just drilling down into each of those things. Actually, in our view, a cloud-native application doesn't need to be deployed in containers. It should be possible to deploy in containers, but you can perfectly well deploy a cloud-native application in a virtual machine if you so wish. The decomposition into microservices is a really important aspect here, because the microservices approach allows you to create architectures that scale out. That means you want more scale, you instantiate more virtual machines or workloads of the same type, and you load balance across them, and that gives you massive scalability, N plus K redundancy and geo redundancy. You know, these are all incredibly valuable and important aspects of cloud nativeness. So microservices is critical. And then the third piece is dynamically orchestrated. And what that means in practice is it should be possible to deploy the entire system, a large-scale system, at the push of a button. It should be possible to automate completely functions like healing when a workload fails, scaling when you need more capacity, and software upgrade, which is another really important thing. Upgrading the software on a traditional network appliance, sometimes across a big population of those takes months or even years to deploy. In a cloud-native application, you can do a rolling upgrade without even having a maintenance window. In other words, the software is in service, and while it's in service, you're just progressively upgrading each of the workloads as you go along. That's what cloud native actually means in practice.
So if containers aren't essential, what's the rationale for moving that way?
Well, containers make life a lot easier. Containers are faster to deploy, they're more portable, and that becomes important when we start talking about hybrid cloud, because there's increasing interest in running some of these workloads in the public cloud. The other nice thing about containers is that containers come with a lifecycle management environment, namely Kubernetes. And the Cloud Native Computing Foundation is behind that particular project. But Kubernetes essentially takes care of load balancing and scale out and healing and software upgrade. They're all automated through Kubernetes. So that kind of comes for free, if you like, with the container environment, as opposed to more traditional VM environment, where typically you need a separate orchestrator or lifecycle manager to come along and do those things.
So is there an acceptance now that we are operating in a cloud world? It's a multi-cloud environment as well, and we are integrating not just private but public clouds into the offerings?
Well, I think it's relatively early days, I think, for telcos on that. There's still a lot of nervousness about whether public cloud is sufficiently secure and sufficiently robust to support telco workloads. But we're certainly seeing an increasing openness of mind to that possibility. I mean, for a couple of years now, we've been demonstrating cloud bursting, namely running a workload like an IMS in a private cloud, but then having the possibility of expanding seamlessly into a public cloud, either for the purpose of geo-redundancy, disaster recovery, or for handling excess capacity requirements. You get a hurricane, and all of a sudden, everyone wants to call to see whether their relatives are okay, right? So, a typical telephone network is overwhelmed by that because it's dimensioned to a fixed peak. But if you can burst the excess capacity into a public cloud, then, without having to make a big capital investment in excess capacity, you can absorb that.
We're also starting to hear over the last few months about the evolution of virtual network functions to cloud-native network functions. Is this semantics, or is there more to it?
Well, I think it's semantics, yes. I mean, I think it's good to make the distinction, but it's still possible to abuse it. And I think the difficulty we're seeing is that all the VNF vendors are saying, oh, we're cloud-native. But without any real substance behind those claims. And of course that's causing a lot of confusion. Hence the words I referred back to in that keynote where people were saying, or the speaker was saying, cloud native is not enough. And that, I think he may be getting that impression because he's being presented with a picture of cloud native from one of the big equipment vendors that isn't truly cloud native. And he's saying, well, you need all these other things. Well, if that application truly was cloud native, those other things would be kind of taken care of.
With so many CSPs investing so much in NFV, what's the role of NFV in cloud native architectures?
Well, cloud native is NFV done right. That's the way we look at it. I mean, the unfortunate thing is that the original vision of NFV was take an appliance that used to be a physical box and turn that into a software appliance and run it virtualized. Now, that vision, which was put out in 2012, I think was very short on kind of long-term thinking, if you like. It represented a baby step. And maybe that was the intention, but maybe it was also a reflection of the lack of understanding of what cloud architected applications look like. It wasn't as though in those days there wasn't plenty of material out there. I mean, you could go on the Netflix technical blog and see a ton of stuff about microservices, about stateless design, massively scalable systems, and so on. So that know-how was out there, and that's the know-how we put to use when we started building cloud-native applications. But maybe the industry wasn't ready for that, and I think it's certainly come to realize that just taking a piece of software from a physical appliance and virtualizing it is not going to yield the benefits that proper cloudification will deliver.
So, as CSPs get more exposed to other industries, cloud providers, hyperscale approaches, new ways of architecting, is that making them more, I guess, open in terms of ideas, in terms of internal culture, how they position themselves for enterprise customers?
Well, it is, but I have to say that it feels like glacially slow progress in terms of internalizing these thoughts and putting them to use. And I mean, to give you another example, there's a class of workloads that you want to deploy on, that telcos want to deploy on clouds, that involve pumping lots of packets. Session border controllers is one example. Mobile packet cores, the user plane where you're handling user traffic. From way back in 2012-13, we've been saying if you have these network intensive workloads, you need to leverage hardware acceleration technologies like SRIAV, single root I/O virtualization. And we've been saying that consistently from the very beginning. Well, 5 years down the line, we've got telcos finally saying, you know what, I think SRIAV might be a good idea. And it's like, well, we told you that a long time ago and you just didn't listen. And they've been struggling to deploy these workloads on overlay networks, which is a nice, elegant way of virtualizing the network, but it doesn't perform for these kinds of workloads. And it's in some ways they took an excessively purist view of cloud, well, cloud has to have a proper virtualized overlay network, you know. Well, okay, that's true, but you've got to be pragmatic about it as well, because the nature of these some of these workloads is different from what you tend to see in, you know, web scale apps.
Well, let's hope that next time we meet, the telco industry has accelerated its glacial strategic thinking. But for now, Martin, as always, thank you very much indeed.
It's a pleasure. Thanks.